G'day. After chatting with a few of my subscribers, I've decided it's worth making not just the 3 long videos explaining how to integrate the basic patterns, but 3 short ones demonstrating the speed as well, without too much of the clutter of the explanation. So to go with my first video, which is describing the 6 basic derivatives and therefore their 6 inverse functions, their 6 integrals, I'm going to show how that pattern would apply here. The first time, actually I'll use 2 colours. Here we have powers of x, and I would write this as a 6 here, x squared, plus 5. Now this is x cubed, but the square root is a power of a half, so it'll be x to the 3 on 2. dx. Now the pattern we need to integrate is 3x squared, so we compensate by dividing the coefficient by 3 as well. And over here, 1 more than this would be 5 on 2, and we would compensate by multiplying this by 2 on 5. I'm using multiplication signs. Strictly speaking, I should be using dots. And all that means is this: 3 into 6 is 2, the integral of 3x squared is x cubed, plus the 5's divide out and leave 2, and the integral of this is x to the 5 on 2 plus c. That's it. By making the adjustments and making sure these patterns fit, the integral is very, very simple indeed. This one here, I would write the 5 on... it's not as fast as I'm making out, is it? I'm very cluttered here trying to do 5 on the one screen. I'm going to write the 5 on 3 out the front and leave the e to the x inside. Do I need any coefficient? Well, no, the integral of e to the x is e to the x, therefore the answer is 5 on 3 e to the x plus c. This one here, integrate, move the 2/3 out the front, 1 on x dx. Do I need any other coefficients? No, that's a pure integral. The integral of 1 over x is log x. Strictly speaking, log absolute value of x. We'll talk about that in another video. This one, move the 3 outside. Is that a pure integral? No. The derivative of cosine is minus sine, or negative sine. So I need a negative sign here. And to compensate, I make the coefficient out the front negative as well, so the 2 negatives make a positive. And that would leave negative 3, integral of this is a pure integral now, cos x plus c. And this one here, we'd move the half out the front. The integral of sec squared is a pure integral, tan x, because the derivative of tan x is sec squared x. The derivative of cosine is minus sine, or negative sine x. Derivative of e to the x is e to the x. Derivative of log x is 1 on x, etc. Now, if you've done a lot of integrating, you'll see these as fairly elementary, perhaps even trivial, but it's to demonstrate the basic patterns involved. And I'm going to leave it at that. There are 2 other videos coming, one showing the chain rule, or at least the inverse of what we call the chain rule when we take the derivatives, and the next one will be, the third one will be integration by parts, which is the reverse of the product rule when we differentiate. So I'll be demonstrating those quickly. Thank you very much for watching. Please like and comment and subscribe, and I look forward to seeing you in the next video.